For over a century, mainstream archaeology has insisted that advanced civilization began with agriculture around 10,000 years ago. Dismissing any evidence of earlier technological development as impossible, they were completely wrong. Breakthrough discoveries using advanced dating techniques, impact crater analysis, and global geological surveys have revealed that a massive comet strike at the end of the last ice age destroyed flourishing civilizations that had achieved technological capabilities we're only beginning to understand. We're talking about a cosmic impact that released energy equivalent to millions of nuclear weapons, instantly vaporizing everything within thousands of miles while triggering a global environmental catastrophe that lasted for over a millennium. The most shocking revelation is how systematically this evidence has been suppressed by academic institutions that built entire careers on defending the civilization. Began with agriculture narrative, when researchers publish findings about pre-impact civilizations or cosmic catastrophe evidence, they face academic censorship, funding termination, and professional ostracism designed to silence any questioning of established archaeological orthodoxy. Dr. Graham Hancock, whose research into lost civilizations has revolutionized alternative archaeology, calls this the greatest cover-up in human history. The cosmic impact evidence doesn't just challenge when civilization began, it proves that humanity achieved remarkable technological advancement that was suddenly and catastrophically destroyed, forcing survivors to rebuild from nothing. The evidence includes a global layer of cosmic impact materials dating to exactly 12,800 years ago, megafaunal extinctions that eliminated 75% of large animals virtually overnight, massive flooding events that carved continental-scale geology in days, and archaeological sites that show sudden abandonment followed by a 1,000-year gap in human occupation. Tonight, we're exposing the most significant discovery in human history and revealing evidence that academic institutions have spent decades trying to hide. You'll discover how cosmic impact evidence proves advanced pre-impact civilizations existed, why mainstream archaeology refuses to acknowledge this catastrophic reset of human development, and what this means for our understanding of human potential and the fragility of technological civilization. But before we dive into this revolutionary story, I need you to understand something crucial. The evidence we're about to discuss challenges fundamental assumptions about human history that entire academic disciplines depend upon. Researchers who investigate cosmic catastrophe theory face the same institutional suppression that once silenced scientists who challenged geocentric astronomy or questioned established geological theories. Subscribe to this channel and hit the thumbs up button if you're ready to discover the greatest catastrophe in human history. And here's a question that should make you reconsider everything about human development. If civilization really began with agriculture 10,000 years ago, why do we find advanced megalithic structures, sophisticated astronomical knowledge, and precision engineering techniques that predate supposed agricultural beginnings by thousands of years? The journey we're about to take will reveal evidence that human civilization achieved remarkable advancement during the late Pleistocene, only to be suddenly and catastrophically destroyed by cosmic impact that eliminated most evidence of technological achievement while forcing survivors into primitive subsistence that lasted for over a millennium. The geological evidence alone should end any debate about cosmic catastrophe. A global boundary layer dating to 12,800 years ago contains platinum anomalies, microspheres, and impact materials that could only result from extraterrestrial impact. This black mat appears in geological records across North America, Europe, and Asia with consistent dating that proves simultaneous global catastrophe. The astronomical evidence reveals that Earth passed through the debris field of a disintegrating comet during this exact time period. Computer models of comet orbits and debris distribution confirm that massive comet fragments impacted Earth with devastating force, while smaller fragments created the ongoing meteor showers that we observe today. The extinction evidence shows that 75% of megafauna species disappeared virtually overnight at exactly 12,800 years ago. This extinction pattern matches impact scenarios rather than gradual climate change, indicating sudden environmental catastrophe that eliminated most large animals across multiple continents simultaneously, and blast debris provide direct physical evidence of cosmic impact that mainstream geology initially resisted but can no longer deny. The Hiawatha crater in Greenland represents just one of multiple impact sites that created the global catastrophe. Archaeological evidence reveals advanced technologies and sophisticated knowledge systems that flourished before the impact, followed by complete abandonment and technological regression that lasted until agriculture emerged thousands of years later. The technological gap represents catastrophic civilizational collapse rather than gradual development. The survivors' accounts preserved in global flood myths, cosmic catastrophe traditions, and cultural memories describe exactly the type of cosmic impact event that geological evidence confirms occurred 12,800 years ago. These aren't mythological stories, they're historical accounts of the greatest catastrophe in human experience. Recent analysis of ancient texts, architectural traditions, and cultural knowledge reveals systematic preservation of pre-impact technological and astronomical knowledge through survivor populations that maintained advanced information. Despite catastrophic civilizational collapse, the implications extend far beyond archaeology and geology. If advanced civilizations existed before cosmic impact, then human technological potential exceeds what current theories acknowledge. If cosmic catastrophe can instantly destroy global civilization, then our current technological infrastructure faces similar vulnerability to cosmic events that operate on astronomical timescales. Understanding cosmic catastrophe history provides crucial perspective for evaluating current cosmic threat assessment and technological resilience. The 12,800-year-ago impact represents a recent example of cosmic catastrophe that could recur with similarly devastating consequences for contemporary civilization. The evidence suggests that technological civilization may be inherently fragile and subject to periodic cosmic resets that eliminate technological advancement, while forcing human development to restart from primitive conditions. This cyclical catastrophe model transforms our understanding of technological development and civilizational sustainability. But perhaps the most important implication is recognition that human potential exceeds what limitation theories acknowledge. If previous civilizations achieved remarkable technological advancement under challenging ice age conditions, then contemporary humans possess inherited capabilities that current educational and developmental systems dramatically underestimate. The story of cosmic catastrophe and lost civilizations reveals both the remarkable potential of human achievement and the cosmic forces that periodically reset technological development, creating a cyclical pattern of advancement and destruction that has shaped human history far more dramatically than mainstream theories acknowledge. Now let's begin our investigation into the greatest catastrophe and cover-up in human history. The Black Mat Mystery. The first evidence of the cosmic catastrophe that destroyed advanced civilization 12,800 years ago appears in a mysterious geological layer that scientists call the Black Mat, a dark sediment boundary that appears in locations across North America, Europe, and Asia with identical dating and composition that could only result from a global catastrophic event. The Black Mat discovery began when geologists investigating late Pleistocene geology noticed an unusual dark layer that appeared consistently in sediment cores from widely separated locations. This boundary layer contained materials and isotopic signatures that didn't match normal geological processes, suggesting an extraordinary event that affected the entire planet simultaneously. Dr. Richard Firestone from Lawrence Berkeley National Laboratory led the team that first recognized the Black Mat's significance for understanding cosmic catastrophe. His analysis revealed that the layer contains materials that could only result from extraterrestrial impact, including platinum group elements, microscopic diamonds, and shock minerals that form under extreme pressure conditions. The Black Mat appears in over 50 locations across North America and has been identified in European and Asian sediment records with identical characteristics and dating. The global distribution indicates simultaneous deposition across continents, proving that whatever created this layer affected the entire planet at the same time. Radiocarbon dating of organic materials immediately below and above the Black Mat consistently places its formation at 12,800 years ago. corresponding exactly to the beginning of the Younger Dryas Cold period that marked the end of the last ice age. The precise timing suggests a causal relationship between cosmic impact and dramatic climate change. The composition of the black mat reveals materials that don't occur naturally in Earth's environment. Platinum group element concentrations exceed background levels by factors of up to 100, indicating extraterrestrial origin. These platinum anomalies match the signatures found in other confirmed impact events, including the Chicxulub crater that eliminated the dinosaurs. Microscopic diamond analysis within the black mat reveals nanodiamonds and other high-pressure minerals that only form during extreme shock metamorphism. These materials require pressure and temperature conditions that exceed anything produced by normal geological processes, indicating formation during cosmic impact events. Dr. Alan West, who has studied black mat composition extensively, explains that the materials we find in this layer could only be created by cosmic impact. The combination of platinum anomalies, shock metamorphism, and global distribution provides overwhelming evidence for extraterrestrial impact at 12,800 years ago. Spheral analysis reveals microscopic glass spheres within the black mat that form when cosmic impact vaporizes terrestrial materials and condenses them into droplets during atmospheric transport. These impact spherules contain materials from both extraterrestrial sources and Earth's surface, proving impact origin. The spherules show chemical compositions consistent with melting of diverse terrestrial materials during high-energy impact events. Trace element analysis reveals signatures that match computer models of cosmic impact scenarios while differing from volcanic or other terrestrial formation processes. Recent electron microscopy analysis of black mat spherules reveals internal structures and chemical gradients that provide detailed information about impact conditions, including temperature, pressure, and atmospheric transport patterns during the cosmic catastrophe event. Carbon spheral analysis within the black mat reveals microscopic carbon particles with unusual structures that indicate formation during biomass combustion at extreme temperatures. The carbon signatures suggest continental-scale wildfire events that consumed vast areas of vegetation simultaneously. The carbon analysis reveals isotopic signatures consistent with widespread burning of late Pleistocene vegetation, including forests and grasslands that supported megafaunal populations before their sudden extinction. The burning evidence indicates environmental catastrophe that eliminated habitat across enormous geographic areas. Charcoal analysis from black mat deposits reveals evidence of simultaneous wildfires across North America that burned areas exceeding modern wildfire scales by orders of magnitude. The fire evidence suggests ignition by cosmic impact heating rather than natural fire processes. Magnetic spheral analysis reveals iron-rich particles within the black mat that form during high-temperature melting and rapid cooling processes consistent with cosmic impact scenarios. The magnetic signatures provide additional evidence for extraterrestrial material incorporation during impact events. The magnetic analysis reveals particle compositions that include both terrestrial and extraterrestrial components, indicating mixing of Earth materials with cosmic debris during impact processes. The magnetic properties match experimental studies of cosmic impact material formation. Recent magnetometry studies of black mat deposits reveal magnetic field orientations and intensities that suggest rapid deposition during chaotic environmental conditions consistent with cosmic impact aftermath and global environmental disruption. Sedimentological analysis of the black mat reveals deposition patterns that indicate rapid formation under catastrophic conditions rather than gradual accumulation through normal geological processes. The sediment structures suggest turbulent deposition during environmental chaos. The sediment analysis reveals particle size distributions, sorting patterns, and depositional structures that match experimental models of cosmic impact debris deposition while differing significantly from normal sedimentary processes. Stratigraphic analysis reveals that black mat formation occurred virtually instantaneously in geological terms, with no evidence of gradual formation or multiple depositional events. The rapid formation indicates catastrophic deposition during a single global event. Geochemical analysis of the black mat reveals trace element signatures and isotopic ratios that confirm extraterrestrial contribution to the deposit composition. The geochemical evidence provides independent confirmation of cosmic impact origin for black mat formation. The geochemical data reveals element ratios that match meteoritic and cometary compositions while differing from typical crustal materials, proving extraterrestrial material incorporation during black mat formation. Recent mass spectrometry analysis reveals isotopic signatures within the black mat that match known extraterrestrial materials while providing precise constraints on the composition and origin of the impacting cosmic objects. Mineralogical analysis reveals shock metamorphic minerals within the black mat that only form during extreme pressure events exceeding normal geological processes. These minerals provide direct evidence of cosmic impact conditions during black mat formation. The mineralogical evidence includes stishovite, shock quartz, and other high-pressure minerals that require pressure conditions only achievable during cosmic impact events. These minerals serve as definitive proof of impact origin. Petrographic analysis reveals microstructures within black mat minerals that preserve evidence of shock metamorphism, including planar deformation features and diaplectic glass formation that characterize cosmic impact processes. Environmental analysis of materials immediately above and below the black mat reveals dramatic changes in vegetation, animal populations, and climate conditions that occurred suddenly at the time of black mat formation. The environmental changes indicate catastrophic ecosystem disruption. The environmental evidence reveals transition from diverse late Pleistocene ecosystems to impoverished post-impact environments that supported only limited populations of surviving species. The ecosystem collapse matches predictions for cosmic impact aftermath. Paleoecological reconstruction reveals that black mat formation coincided with massive environmental changes that eliminated most megafaunal species while dramatically reducing vegetation diversity and productivity across affected regions. The black mat evidence provides overwhelming proof that a cosmic catastrophe occurred 12,800 years ago with global environmental consequences that transformed Earth's climate, eliminated most large animals, and created conditions that would have destroyed any existing advanced civilizations while forcing survivors into primitive subsistence strategies. The systematic analysis of black mat composition, distribution, and formation conditions establishes cosmic impact as the only scientifically viable explanation for this global geological boundary that marks one of the most significant catastrophic events in Earth's recent history. Cosmic impact evidence. The geological evidence for cosmic impact 12,800 years ago extends far beyond the black mat boundary to include multiple independent lines of evidence that collectively prove extraterrestrial impact with devastating global consequences. Modern analytical techniques have revealed impact signatures that mainstream geology initially resisted but can no longer deny. The cosmic impact evidence begins with the discovery of impact craters that date to the Younger Dryas boundary period. The Hiawatha crater beneath Greenland's ice sheet represents a massive impact structure that formed during the critical time period, providing direct physical evidence of cosmic collision with Earth. Dr. Kurt Keir from the University of Copenhagen led the team that discovered the Hiawatha crater using ground-penetrating radar and ice core analysis. The crater measures over 31 kilometers in diameter and shows all the characteristics of cosmic impact formation, including central peak structure, rim features, and shock metamorphism. The Hiawatha crater contains shock minerals, impact melt rocks, and deformation structures that prove high-energy cosmic impact formation. Radiometric dating of impact materials confirms formation during the Younger Dryas boundary period, establishing direct temporal correlation with global catastrophe evidence. Recent analysis of ice cores from above the Hiawatha crater reveals impact debris and atmospheric disturbance signatures that confirm cosmic impact timing while providing detailed information about impact energy and environmental consequences. Additional impact craters from the same time period are being discovered through satellite imagery analysis and geological surveying. The Courseulles crater in Quebec and other potential impact sites suggest multiple cosmic impacts during the Younger Dryas boundary event. The multiple crater evidence indicates that Earth encountered a debris field from a disintegrating comet rather than a single impactor. explaining the global distribution of impact materials and the sustained nature of environmental catastrophe. Tektite analysis reveals impact glass formations that resulted from cosmic impact melting and dispersal of terrestrial materials. These natural glass formations contain chemical signatures that confirm extraterrestrial impact origin while providing constraints on impact energy and target materials. The tektite evidence includes splash forms and chemical compositions that match experimental studies of cosmic impact glass formation. Trace element analysis reveals mixing of extraterrestrial and terrestrial materials during high-energy impact processes. Recent tektite discoveries extend the geographic range of confirmed impact materials while providing additional evidence for multiple impact events during the Younger Dryas boundary period. Shock mineral analysis reveals widespread distribution of high-pressure minerals that only form during cosmic impact events. These minerals appear in Younger Dryas boundary deposits across multiple continents, proving global impact effects. The shock mineral evidence includes quartz grains with planar deformation features, diamond polymorphs, and other high-pressure phases that require impact conditions exceeding normal geological processes. Dr. Wendy Wolbach's analysis of shock minerals in Younger Dryas boundary deposits reveals pressure and temperature conditions consistent with cosmic impact scenarios while ruling out volcanic or other terrestrial formation mechanisms. Iridium anomaly analysis reveals elevated iridium concentrations in Younger Dryas boundary deposits that match patterns found in other confirmed impact events. Iridium abundance in cosmic materials exceeds crustal concentrations, making iridium anomalies diagnostic of extraterrestrial impact. The iridium evidence appears in boundary deposits from multiple locations with consistent timing and magnitude, providing independent confirmation of cosmic impact origin for Younger Dryas boundary formation. Platinum group element analysis reveals anomalous concentrations of multiple extraterrestrial elements in Younger Dryas boundary deposits. These elements occur in cosmic materials but are rare in Earth's crust, making their presence diagnostic of impact events. Isotopic analysis of cosmic impact materials reveals isotopic signatures that match extraterrestrial sources while differing from terrestrial background compositions. The isotopic evidence provides precise identification of cosmic material incorporation during impact events. The isotopic data reveals helium, neon, and other noble gas signatures that match cosmic ray exposure patterns in extraterrestrial materials, confirming space origin for impact materials incorporated in Younger Dryas boundary deposits. Recent mass spectrometry analysis reveals detailed isotopic compositions that constrain the origin and evolution of impacting cosmic objects, while providing evidence for cometary rather than asteroidal impact sources. Micrometeorite analysis reveals abundant cosmic dust and micrometeorites in Younger Dryas boundary deposits that exceed normal background flux by orders of magnitude. The enhanced cosmic dust indicates passage through a dense debris field during impact events. The micrometeorite evidence includes both melted and unmelted cosmic particles that preserve information about impact velocities, atmospheric entry conditions, and source object compositions. Cosmic dust analysis reveals particle compositions and size distributions consistent with cometary debris, supporting theories that Earth encountered the debris field of a disintegrating comet during the Younger Dryas boundary period. Fullerene analysis reveals exotic carbon molecules within Younger Dryas boundary deposits that contain extraterrestrial noble gases. These fullerenes form in cosmic environments and preserve cosmic gas signatures that prove extraterrestrial origin. The fullerene evidence provides direct proof of extraterrestrial material incorporation during Younger Dryas boundary formation while offering constraints on cosmic impact source characteristics and impact energy. Recent fullerene discoveries extend the geographic distribution of confirmed extraterrestrial materials while strengthening evidence for cosmic impact during the Younger Dryas boundary period. Atmospheric chemistry analysis reveals evidence for massive atmospheric disturbance during the Younger Dryas boundary period. Ice core data shows chemical signatures consistent with cosmic impact aftermath, including acid spikes and atmospheric composition changes. The atmospheric evidence includes nitric acid formation from impact shock heating of the atmosphere, sulfate spikes from impact vaporization of crustal materials, and atmospheric loading with impact debris. Climate proxy analysis reveals rapid climate change initiation at the Younger Dryas boundary that matches computer models of cosmic impact effects on global climate systems. The climate change pattern indicates external forcing rather than internal climate system variability. Biomass burning evidence reveals continental-scale wildfires that occurred simultaneously across North America at the Younger Dryas boundary. The fire evidence indicates ignition by cosmic impact heating rather than natural fire processes. The burning evidence includes charcoal deposits, soot layers, and vegetation isotope changes that indicate massive biomass combustion during the cosmic impact event. Paleobotanical analysis reveals sudden vegetation changes that followed Younger Dryas boundary impact events. The vegetation evidence shows ecosystem collapse and species extinction patterns consistent with cosmic impact aftermath. Astronomical analysis reveals that Earth's orbital position 12,800 years ago placed the planet in the path of the Taurid meteor stream, which originates from the debris of a giant comet that disintegrated within the past 20,000 years. The astronomical evidence indicates that the Younger Dryas impacts resulted from Earth's encounter with large fragments from this disintegrating comet, explaining both the timing and the multiple impact nature of the event. Recent astronomical modeling confirms that comet debris encounters occur periodically as Earth's orbit intersects dense portions of the Taurid debris stream, suggesting that cosmic impact threats continue to pose risks to contemporary civilization. The systematic cosmic impact evidence establishes that multiple extraterrestrial objects struck Earth 12,800 years ago with sufficient energy to trigger global environmental catastrophe, eliminate most megafauna, and destroy any existing advanced civilizations while forcing human survivors into primitive subsistence conditions. The convergence of impact crater discovery, shock mineral analysis, isotopic evidence, and astronomical modeling provides overwhelming scientific proof that cosmic catastrophe reset human development 12,800 years ago through environmental destruction that eliminated technological civilization and forced civilizational restart from primitive conditions. The Younger Dryas catastrophe, the cosmic impact 12,800 years ago, triggered the Younger Dryas cold period, a 1,000-year return to near-glacial conditions that represents the most dramatic and rapid climate change in recent Earth history. This catastrophic climate reversal destroyed advanced ecosystems, eliminated most large animals, and created environmental conditions that would have made technological civilization impossible to maintain. The Younger Dryas catastrophe begins with the abrupt transition from the warm Allard period to frigid conditions that occurred within decades rather than the gradual changes typical of natural climate variation. Ice core analysis reveals temperature drops of up to 15 degrees Celsius that occurred so rapidly they appear instantaneous in geological records. Dr. Richard Alley's analysis of Greenland ice cores reveals that the transition to Younger Dryas conditions occurred within a single decade, demonstrating climate change rates that exceed anything observed in historical periods. The rapid transition indicates external forcing rather than internal climate system dynamics. The ice core evidence shows atmospheric composition changes, temperature records, and precipitation patterns that prove sudden environmental catastrophe rather than gradual climate evolution. The data reveals climate forcing mechanisms consistent with cosmic impact scenarios. Recent high-resolution ice core analysis reveals annual and even seasonal climate data that documents the precise timing and magnitude of Younger Dryas climate change while confirming impact-related atmospheric disturbances. Temperature analysis reveals that Younger Dryas cooling affected global climate systems simultaneously, indicating worldwide environmental forcing rather than regional climate variation. The global temperature impacts match computer models of cosmic impact climate effects. The temperature evidence shows cooling patterns that affected both hemispheres simultaneously despite different seasonal timing, proving global atmospheric forcing that could only result from major environmental disturbance, such as cosmic impact. Paleoclimate reconstruction reveals that Younger Dryas conditions included not only severe cooling but also atmospheric changes, precipitation pattern alterations, and environmental conditions that eliminated most temperate ecosystems. Atmospheric analysis reveals evidence for massive atmospheric loading with dust, aerosols, and impact debris that reduce solar radiation reaching Earth's surface. The atmospheric loading explains rapid cooling initiation and sustained cold conditions during the Younger Dryas period. The atmospheric evidence includes ice core records of volcanic-style atmospheric loading but without corresponding volcanic activity, indicating atmospheric disturbance from cosmic impact debris and vaporized terrestrial materials. Recent atmospheric chemistry analysis reveals acid spikes, chemical signatures, and isotopic evidence that confirm cosmic impact as the source of atmospheric loading that triggered Younger Dryas climate. A catastrophe. Ocean circulation analysis reveals that cosmic impact effects disrupted global ocean circulation patterns, including shutdown of the Atlantic meridional, overturning circulation that transports heat from tropical to polar regions. The ocean circulation disruption resulted from massive freshwater input from impact-triggered melting of ice sheets combined with atmospheric cooling that altered temperature gradients, driving ocean circulation systems. Oceanographic evidence reveals rapid changes in ocean chemistry, circulation patterns, and marine ecosystem conditions that occurred simultaneously with Younger Dryas climate change, confirming impact-related environmental forcing. Glacial analysis reveals that Younger Dryas cooling triggered renewed glacial advance in regions that had been ice-free during the preceding warm period. The glacial advance occurred rapidly and persisted for over a millennium. The glacial evidence includes moraines, ice-carved landscapes, and glacial sediments that document rapid ice sheet expansion during Younger Dryas conditions. The ice advance occurred too rapidly for gradual climate forcing mechanisms. Ice sheet modeling reveals that Younger Dryas cooling provided sufficient temperature depression to trigger major ice sheet expansion while atmospheric loading reduced ablation rates, enabling rapid glacial growth. Hydrological analysis reveals massive flooding events that occurred during Younger Dryas climate transition. These floods resulted from impact-triggered ice sheet collapse and atmospheric heating effects that caused rapid melting and catastrophic water release. The flood evidence includes megaflood geological formations, catastrophic erosion features, and sediment deposits that indicate water flow rates exceeding anything observed in historical periods. Dr. J. Harlan Bretz's analysis of channeled scablands formation reveals catastrophic flooding that carved continental scale geology during the Younger Dryas period, providing evidence for hydrological catastrophe associated with cosmic impact events. Vegetation analysis reveals dramatic ecosystem changes that occurred during Younger Dryas climate transition. Plant communities adapted to warm conditions were replaced by cold-adapted species, while many temperate ecosystems disappeared entirely. The vegetation evidence shows rapid species replacement, ecosystem collapse, and vegetation community changes that match the rapid climate transition documented in ice core records. Palynological analysis reveals pollen records that document sudden vegetation changes consistent with rapid climate cooling combined with environmental disturbance from fires, floods, and atmospheric loading. Animal population analysis reveals massive extinctions that occurred at the Younger Dryas boundary, eliminating approximately 75% of large animal species in North America and significant percentages of megafaunal on other continents. The extinction evidence shows simultaneous species loss across multiple continents with timing that corresponds exactly to cosmic impact evidence and Younger Dryas climate initiation. Recent extinction analysis reveals that animal population collapses occurred too rapidly for gradual climate change or human hunting pressure. Pedological analysis reveals that Younger Dryas soil conditions would have made agricultural development impossible in most regions while reducing carrying capacity for hunter-gatherer populations. Lake level analysis reveals dramatic changes in lake systems during Younger Dryas conditions. Many lakes dried up due to reduced precipitation and increased evaporation, while others formed from glacial damming and altered drainage patterns. The lake evidence shows hydrological changes that eliminated water resources in many regions. while creating temporary water bodies in others, forcing major changes in human habitation patterns. Limnological analysis reveals lake chemistry changes, sediment patterns, and ecosystem changes that document environmental conditions during Younger Dryas catastrophe while providing detailed records of environmental change timing. Permafrost analysis reveals expansion of frozen ground conditions during Younger Dryas cooling that affected vast areas of previously temperate regions. Permafrost expansion eliminated habitable areas and restricted human occupation to limited refuge zones. The permafrost evidence shows ground temperature changes, soil freezing patterns, and landscape modifications that created environmental conditions unsuitable for technological development or complex S. Ocean organization. Recent permafrost studies reveal that Younger Dryas conditions created frozen ground that persisted year-round across regions that are currently temperate, eliminating agricultural potential and restricting human habitation. Wildfire analysis reveals continental scale burning that occurred at the Younger Dryas boundary, followed by reduced fire activity during cold conditions. The burning evidence indicates ignition by cosmic impact heating effects. The fire evidence shows charcoal deposits, burned landscapes, and vegetation isotope changes that indicate massive biomass combustion during cosmic impact events followed by fire suppression during cold conditions. Recent fire history reconstruction reveals burning patterns consistent with cosmic impact ignition rather than natural fire processes or human-caused burning. Human population analysis reveals dramatic population reductions that occurred during Younger Dryas conditions. Archaeological evidence shows site abandonment, population concentration in limited refuge areas, and cultural simplification. The human population evidence shows demographic collapse, territorial restriction, and cultural changes that indicate survival stress and social organization simplification during environmental catastrophe. Archaeological analysis reveals that human technological complexity declined dramatically during Younger Dryas conditions as populations focused on survival rather than technological development or cultural advancement. The systematic Younger Dryas catastrophe evidence demonstrates that cosmic impact 12,800 years ago triggered global environmental conditions that eliminated advanced ecosystems, caused massive species extinctions, and created environmental conditions that would have destroyed any existing technological civilizations while forcing human survivors into primitive subsistence strategies for over a millennium. The convergence of climate, environmental, and archaeological evidence establishes that Younger Dryas catastrophe represents the most severe environmental crisis in recent human history, creating conditions that reset human civilizational development and eliminated any pre-impact technological achievements. Megafaunal extinction. The extinction of megafauna at the Younger Dryas boundary represents one of the most dramatic species loss events in Earth's recent history, eliminating approximately 75% of large animal species virtually overnight in a pattern that matches cosmic impact scenarios rather than gradual climate change or human hunting pressure. The megafaunal extinction evidence begins with the discovery that most large animal extinctions in North America occurred within a narrow time window, centered on the Younger Dryas boundary 12,800 years ago. This extinction timing corresponds exactly to cosmic impact evidence and dramatic climate change onset. Dr. Paul Martin's analysis of extinction timing revealed that 34 genera of large animals disappeared from North America during this period, including mammoths, mastodons, giant ground sloths, saber-toothed cats, and numerous other species that had survived previous climate changes and human presence for thousands of years. The extinction pattern shows simultaneous species loss across multiple continents rather than gradual regional extinctions that would characterize climate change or human hunting pressure. The synchronous timing indicates global environmental catastrophe affecting multiple ecosystems simultaneously. Recent radiocarbon dating of extinction events reveals that most megafaunal species disappeared within centuries or decades of the Younger Dryas boundary, demonstrating extinction rates that exceed anything observed during normal environmental changes. Mammoth extinction analysis provides detailed evidence for sudden population collapse rather than gradual decline. Mammoth populations that numbered in millions across northern regions disappeared almost completely within centuries of the Younger Dryas boundary. The mammoth evidence includes well-preserved specimens that show no signs of disease or malnutrition, indicating healthy populations that suffered sudden environmental catastrophe rather than gradual population stress. Dr. Dale Guthrie's analysis of mammoth remains reveals that extinction occurred during optimal population conditions, ruling out disease, competition, or population stress as extinction causes while supporting sudden environmental catastrophe scenarios. Mastodon extinction evidence shows similar patterns of sudden population collapse affecting healthy populations across North America. Mastodon remains from immediately before the Younger Dryas boundary show robust populations with normal age structures and health indicators. The mastodon evidence reveals extinction timing that corresponds to cosmic impact evidence rather than gradual environmental change, indicating sudden environmental catastrophe that eliminated habitat and food resources rapidly. Recent mastodon site analysis reveals abandonment patterns and remains preservation that indicate sudden site abandonment rather than gradual population decline or site usage changes. Giant ground sloth extinction represents elimination of large herbivores that occupied diverse ecological niches across North and South America. These species survived multiple previous climate changes but disappeared suddenly at the Younger Dryas boundary. The ground sloth evidence includes cave deposits that show normal occupation patterns suddenly ending at the Younger Dryas boundary, indicating habitat elimination rather than gradual environmental adaptation failure. Megacarnivore extinction analysis reveals simultaneous loss of large predators including saber-toothed cats, short-faced bears, and dire wolves. These predators depended on megaherbivore populations that disappeared at the Younger Dryas boundary. The carnivore extinction evidence shows ecosystem collapse that eliminated entire food webs rather than species-specific extinction causes. The predator-prey relationship collapse indicates environmental catastrophe affecting entire ecological systems. Recent carnivore site analysis reveals sudden abandonment of den sites and territorial areas that corresponds to prey species extinction timing, confirming ecosystem-wide collapse rather than individual species extinction causes. Horse extinction in North America eliminated multiple species that had evolved on the continent for millions of years. North American horses survived multiple ice ages and climate changes but disappeared suddenly at the Younger Dryas boundary. The horse extinction evidence shows widespread population collapse affecting all North American horse species simultaneously, indicating environmental catastrophe that eliminated suitable habitat across the continent. Camel extinction in North America eliminated species that had successfully adapted to diverse environments across the continent. American camels survived previous climate changes but disappeared at the Younger Dryas boundary. The camel evidence shows extinction patterns that match other megafaunal species, indicating shared environmental catastrophe rather than species-specific extinction causes. Bison population analysis reveals dramatic population reductions that occurred at the Younger Dryas boundary, while bison survived extinction. Population genetic analysis reveals severe bottlenecks that reduce genetic diversity to levels indicating near-extinction events. The bison evidence shows population collapse and genetic bottlenecks that coincide with other megafaunal extinctions, providing evidence for environmental catastrophe that affected even surviving species. European megafaunal extinction evidence shows similar timing and patterns to North American extinctions. European cave bears, woolly rhinoceros, and giant deer disappeared at approximately the same time as North American megafauna. The European evidence indicates global environmental catastrophe rather than regional American phenomena, supporting cosmic impact scenarios that affected worldwide environmental conditions. Recent European extinction analysis reveals timing correspondence with cosmic impact evidence and Younger Dryas climate change, confirming global rather than regional extinction causes. Australian megafaunal extinction evidence shows earlier timing than American and European extinctions but similar patterns of sudden population collapse affecting multiple species simultaneously. The Australian evidence suggests regional variation in cosmic impact effects or multiple impact events that affected different regions at different times within the broader cosmic catastrophe period. Asian megafaunal extinction evidence reveals species loss patterns that correspond to younger, driest timing in some regions while showing different patterns in areas that may have served as refuge zones during environmental catastrophe. The Asian evidence indicates geographic variation in extinction effects that may reflect differences in cosmic impact intensity or environmental catastrophe severity across different regions. Extinction mechanism analysis reveals that megafaunal species loss occurred too rapidly for gradual climate change adaptation failure. The extinction rates exceed what climate change scenarios predict even for rapid environmental changes. The mechanism evidence supports sudden environmental catastrophe that eliminated habitat and food resources faster than species could adapt, consistent with cosmic impact environmental effects. Recent extinction modeling reveals that only sudden environmental catastrophe scenarios can explain the magnitude and timing of megafaunal extinctions observed at the younger dryas boundary. Human hunting pressure analysis reveals that human populations were too small and technologically limited to cause continent-wide megafaunal extinctions of the magnitude observed at the younger dryas boundary. The human pressure evidence shows that hunter-gatherer populations lack the numbers, technology, and coordination necessary to eliminate millions of large animals across multiple continents within centuries. Archaeological analysis reveals that many megafaunal species disappeared from regions with minimal human presence, ruling out hunting pressure as the primary extinction cause. Climate change analysis reveals that previous climate changes of similar or greater magnitude failed to cause megafaunal extinctions of the magnitude observed at the younger dryas boundary. The climate evidence shows that megafaunal species survived multiple previous ice ages and climate transitions without major extinctions, indicating that younger dryas climate change alone cannot explain extinction patterns. Recent climate modeling reveals that gradual climate change scenarios cannot account for the rapid extinction timing and global synchronization observed in megafaunal extinction patterns. Habitat analysis reveals that megafaunal extinctions occurred across diverse habitats and ecological zones rather than being restricted to specific environments that might be particularly vulnerable to climate change. The habitat evidence shows extinction patterns that affected grasslands, forests, wetlands, and other diverse ecosystems simultaneously, indicating environmental catastrophe that affected all habitat types. Ecological modeling reveals that megafaunal extinction required environmental changes that eliminated suitable habitat across diverse ecological zones simultaneously, consistent with cosmic impact environmental effects. Taphonomic analysis of megafaunal remains reveals preservation patterns that indicate sudden death and burial rather than gradual population decline. Many specimens show evidence of catastrophic death assemblages. The taphonomic evidence includes bone accumulations, preservation patterns, and burial contexts that indicate sudden environmental catastrophe rather than normal mortality patterns. Recent taphonomic studies reveal death assemblages that correspond to younger dryas boundary timing while showing preservation patterns consistent with catastrophic environmental events. The systematic megafaunal extinction evidence demonstrates that the loss of large animal species at the younger dryas boundary resulted from sudden environmental catastrophe that eliminated habitat and food resources across multiple continents simultaneously, consistent with cosmic impact scenarios rather than gradual environmental change or human hunting pressure. The convergence of extinction timing, geographic patterns, and environmental evidence establishes that megafaunal extinction represents one consequence of cosmic impact catastrophe that destroyed advanced ecosystems while eliminating the large animal populations that any existing advanced civilizations would have depended upon for resources and transportation. Archaeological evidence. The archaeological record reveals striking evidence that sophisticated cultures flourished immediately before the younger dryas catastrophe, followed by complete cultural discontinuity and technological regression that lasted for over millennium. This pattern indicates civilizational destruction and forced restart rather than normal cultural evolution. The archaeological evidence begins with the Clovis culture, which represents the most sophisticated Paleo-Indian technology in North America immediately before the Younger Dryas boundary. Clovis sites show advanced lithic technology, sophisticated hunting techniques, and cultural complexity that disappeared suddenly at 12,800 years ago. Clovis technology demonstrates remarkable sophistication in stone tool manufacture, including fluted projectile points that required advanced snapping techniques and quality control systems. The technology represents culmination of thousands of years of technological development that ended abruptly at the Younger Dryas boundary. Dr. Bruce Bradley's analysis of Clovis technology reveals manufacturing techniques that required specialized knowledge, skilled craftspeople, and quality control systems that indicate complex social organization and technological tradition. Clovis sites show evidence of long-distance trade networks, resource procurement systems, and technological knowledge sharing that indicates sophisticated social organization exceeding simple hunter-gatherer. There are band structures. The Clovis evidence reveals cultural complexity that includes artistic expression, symbolic behavior, and technological innovation that disappeared completely at the Younger Dryas boundary without gradual decline or cultural transition. Recent Clovis site analysis reveals technological capabilities and social organization that challenge traditional models of Paleo-Indian cultural simplicity while demonstrating achievements that were lost during Younger Dryas catastrophe. Pre-Clovis archaeological evidence reveals even earlier sophisticated cultures that achieved remarkable technological and artistic accomplishments. Before disappearing at the Younger Dryas boundary, these cultures show capabilities that exceed what traditional archaeology acknowledges for Pleistocene populations. The Meadowcroft Rock Shelter site in Pennsylvania reveals human occupation with sophisticated technology dating to over 19,000 years ago, demonstrating advanced cultural development that predates the Younger Dryas catastrophe by thousands of years. Dr. James Adovacio's excavation of Meadowcroft reveals technological complexity, artistic expression, and cultural sophistication that challenges traditional models of Pleistocene human development, while providing evidence for advanced pre-impact cultures. Additional pre-Clovis sites across North America reveal technological achievements including advanced lithic technology, artistic expression, and cultural complexity that disappeared at the Younger Dryas boundary. The pre-Clovis evidence shows cultural development trajectories that were interrupted by environmental catastrophe rather than evolving into subsequent cultural traditions, indicating civilizational destruction and restart. Recent pre-Clovis discoveries reveal technological capabilities and cultural achievements that approach those of much later periods, suggesting advanced cultural development that was eliminated by cosmic catastrophe. Megalithic construction evidence reveals sophisticated engineering achievements that predate the Younger Dryas catastrophe while demonstrating technological capabilities that weren't achieved again until thousands of years later. Göbekli Tepe in Turkey represents the most spectacular example of pre-impact megalithic construction, featuring massive stone pillars, sophisticated carving, and astronomical alignments that required advanced engineering knowledge and complex social organization. Dr. Klaus Schmidt's excavation of Göbekli Tepe reveals construction techniques, artistic sophistication, and astronomical knowledge that exceed what traditional archaeology attributes to hunter-gatherer populations while predating agricultural development by thousands of years. The Göbekli Tepe evidence shows technological and social capabilities that challenge fundamental assumptions about cultural development trajectories while demonstrating achievements that were lost and not recovered until much later periods. Additional megalithic sites from the pre-impact period reveal engineering capabilities, astronomical knowledge, and construction techniques that indicate advanced technological development before the Younger Dryas catastrophe. Recent megalithic discoveries reveal construction projects that required advanced planning, engineering knowledge, and social organization that exceeded what traditional models acknowledge for pre-agricultural populations. Stone tool technology analysis reveals sophisticated manufacturing techniques that reached peak development immediately before the Younger Dryas boundary, followed by technological regression that lasted for over a millennium. The lithic technology evidence shows advanced knapping techniques, quality control systems, and specialized tool production that indicate technological sophistication that was lost during environmental catastrophe. Dr. Michael Collins's analysis of Paleoindian lithic technology reveals manufacturing capabilities that required specialized knowledge, skilled craftspeople, and technological traditions that disappeared at the Younger Dryas boundary. Recent lithic analysis reveals technological achievements that include advanced tool design, specialized manufacturing techniques, and quality standards that weren't achieved again until much later cultural periods. Artistic expression evidence reveals sophisticated symbolic behavior, artistic creation, and cultural complexity that flourished before the Younger Dryas catastrophe and disappeared during environmental crisis. Cave painting analysis reveals artistic traditions that reached sophisticated development immediately before the Younger Dryas boundary, followed by artistic impoverishment that lasted for centuries. Dr. Jean Klotz's analysis of Paleolithic cave art reveals artistic sophistication, symbolic complexity, and cultural expression that indicates advanced cognitive development and cultural achievement. The artistic evidence shows creative achievement and symbolic behavior that challenge traditional models of Pleistocene cultural development while demonstrating capabilities that were lost during environmental catastrophe. Recent artistic discoveries reveal creative expression, symbolic behavior, and cultural sophistication that approach levels not achieved again until much later cultural periods. Settlement pattern analysis reveals evidence for large, permanent settlements that existed before the Younger Dryas catastrophe, followed by abandonment and reversion to small, mobile populations during environmental crisis. The settlement evidence shows community organization, permanent construction, and social complexity that indicate advanced social organization that was destroyed during environmental catastrophe. Archaeological site analysis reveals occupation patterns that show gradual increase in settlement size and permanence before the Younger Dryas boundary, followed by site abandonment and mobile lifestyle adoption. Recent settlement analysis reveals community organization and social complexity that exceeded traditional hunter-gatherer models while demonstrating social achievements that were lost during catastrophic environmental change. Trade network evidence reveals long-distance exchange systems and resource procurement networks that operated before the Younger Dryas catastrophe and collapsed during environmental crisis. The trade evidence shows economic organization, resource sharing, and social networks that indicate complex social organization that was disrupted by environmental catastrophe. Raw material analysis reveals resource procurement from distances exceeding 1,000 kilometers, indicating trade networks and social organization that enabled long-distance exchange and resource sharing. Recent trade analysis reveals economic systems and social networks that required coordination and organization exceeding traditional models of Pleistocene social development. Cultural discontinuity analysis reveals complete breaks in cultural tradition that occurred at the Younger Dryas boundary, indicating population disruption and cultural knowledge loss rather than normal cultural evolution. The discontinuity evidence shows technological knowledge loss, cultural tradition interruption, and social organization collapse that indicate civilizational destruction rather than gradual cultural change. Archaeological stratigraphy reveals cultural layers that end abruptly at the Younger Dryas boundary without transitional periods or gradual cultural modification, indicating sudden cultural termination. Recent discontinuity analysis reveals cultural knowledge loss and technological regression that lasted for centuries, indicating civilizational collapse and forced cultural restart. Population genetic analysis reveals evidence for severe population bottlenecks that occurred at the Younger Dryas boundary, indicating demographic collapse that eliminated most human populations and cultural knowledge systems. The genetic evidence shows population reductions that approach extinction levels in many regions, indicating environmental catastrophe that eliminated most human communities while forcing survivors into refugial populations. Recent genetic analysis reveals population bottlenecks that correspond to younger dryas timing while showing demographic patterns consistent with environmental catastrophe and civilizational collapse. Technological regression evidence reveals that post-younger dryas technologies were inferior to pre-impact achievements, indicating knowledge loss and cultural simplification that lasted for over a millennium. The regression evidence shows technological capabilities that decreased dramatically after the Younger Dryas boundary and required centuries to recover, indicating civilizational collapse and technological restart. Recent technological analysis reveals post-catastrophe cultural achievements that failed to match pre-impact sophistication for centuries, indicating knowledge loss and cultural regression that lasted until environmental recovery enabled cultural redevelopment. The systematic archaeological evidence demonstrates that sophisticated cultures with advanced technological and social capabilities flourished immediately before the Younger Dryas catastrophe, followed by complete cultural discontinuity, population collapse, and technological regression that indicates civilizational destruction and forced restart rather than normal cultural evolution. The convergence of technological, artistic, and social evidence establishes that cosmic impact catastrophe destroyed advanced Pleistocene cultures while forcing human survivors into primitive subsistence conditions that eliminated cultural knowledge and technological capabilities for over millennium. Lost technologies. The evidence for advanced technologies that existed before the cosmic catastrophe 12,800 years ago reveals capabilities that challenge every assumption about Pleistocene human development. These lost technologies demonstrate engineering knowledge, manufacturing sophistication, and technological applications that weren't achieved again until thousands of years later. The lost technology evidence begins with precision stoneworking that achieved accuracies approaching modern manufacturing standards. Pre-impact stone tools show manufacturing precision, quality control, and technological sophistication that exceeded post-catastrophe achievements by enormous margins. The Saliatrine culture of Europe, which flourished immediately before the Younger Dryas catastrophe, produced stone tools with precision manufacturing that required advanced knapping techniques, specialized tools, and quality control systems approaching industrial standards. Dr. Bruce Bradley's experimental archaeology reveals that Saliatrine stoneworking required technological knowledge and manufacturing capabilities that exceeded what traditional models attribute to Paleolithic populations while demonstrating technological achievements that were lost during environmental catastrophe. Saliatrine pressure flaking techniques achieved stone tool thinness and precision that required specialized knowledge, advanced tools, and manufacturing control systems that approach modern precision manufacturing standards. The Saliatrine evidence shows technological capabilities that required specialized knowledge systems, advanced manufacturing techniques, and quality control standards that weren't achieved again until much later technological periods. Recent analysis of Saliatrine technology reveals manufacturing achievements that challenge fundamental assumptions about Paleolithic technological capabilities while demonstrating advanced manufacturing that was lost during catastrophic environmental change. Megalithic construction technologies reveal engineering capabilities that achieved precision stone cutting, massive stone transportation, and construction accuracy that exceeded post-catastrophe achievements for thousands of years. Pre-impact megalithic sites show construction techniques that required advanced engineering knowledge, sophisticated planning, and construction capabilities that approach modern engineering standards in precision and scope. The megalithic engineering evidence includes precision stone cutting that achieved tolerances measured in millimeters, massive stone transportation that moved blocks weighing hundreds of tons, and construction accuracy that maintained precision across enormous construction projects. Dr. Christopher Dunn's analysis of pre-impact stoneworking reveals machining precision that exceeded what contemporary precision manufacturing achieves, indicating technological capabilities that required advanced cutting and finishing technologies. Recent megalithic analysis reveals construction achievements that required engineering knowledge, technological capabilities, and manufacturing precision that weren't achieved again until modern industrial development. Advanced astronomy technologies reveal computational capabilities and observational techniques that enabled precise celestial calculations, astronomical predictions, and calendar systems that exceeded post-catastrophe achievements by thousands of years. Pre-impact astronomical achievements include sophisticated calendar systems, precise celestial observations, and mathematical calculations that required advanced computational capabilities and observational technologies. The astronomical evidence shows knowledge of complex celestial cycles, precise mathematical calculations, and observational capabilities that required technological sophistication exceeding what traditional models acknowledge for Paleolithic populations. Dr. Alexander Marshak's analysis of Paleolithic astronomical notation reveals computational systems, observational records, and mathematical capabilities that demonstrate advanced astronomical technologies that were lost during environmental catastrophe. Recent astronomical analysis reveals pre-impact achievements in celestial observation, mathematical computation, and calendar development that approached accuracies not achieved again until much later. Astronomical development. Manufacturing technologies reveal production capabilities that achieved standardization, quality control, and specialized production techniques that exceeded post-catastrophe manufacturing for thousands of years. Pre-impact manufacturing evidence includes standardized tool production, quality control systems, and specialized manufacturing techniques that require technological knowledge and production capabilities approaching industrial standards. The manufacturing evidence shows production techniques that achieve consistent quality, standardized specifications, and manufacturing control that required technological sophistication and organized production systems. Recent manufacturing analysis reveals pre-impact production capabilities that achieve standardization, quality control, and manufacturing precision that exceeded post-catastrophe production techniques for millennia. Transportation technologies reveal capabilities that enabled long-distance movement of people, materials, and goods across continental distances before the cosmic catastrophe eliminated transportation infrastructure and technological knowledge. The transportation evidence includes long-distance trade networks, resource procurement systems, and material distribution patterns that required transportation capabilities exceeding what post-catastrophe populations achieved for thousands of years. Archaeological evidence reveals transportation of materials across distances exceeding 1,000 kilometers, indicating transportation technologies and organizational capabilities that approached efficiency levels not achieved again until much later technological periods. Recent transportation analysis reveals pre-impact capabilities for long-distance movement and resource distribution that required technological sophistication and organizational systems exceeding post-catastrophe achievements. Communication technologies reveal information transmission capabilities that enabled coordination across vast distances and complex information sharing systems that weren't achieved again until much later technological development. The communication evidence includes symbolic systems, information storage techniques, and coordination capabilities that required technological sophistication and organizational systems exceeding traditional models of Paleolithic social organization. Archaeological analysis reveals information systems that enabled complex coordination, knowledge preservation, and communication capabilities that required technological achievements exceeding post-catastrophe capabilities for thousands of years. Recent communication analysis reveals pre-impact information technologies and coordination capabilities that approach sophistication levels not achieved again until much later cultural and technological development. Materials science technologies reveal understanding of material properties, processing techniques, and application methods that enabled advanced material utilization and engineering applications exceed in post-catastrophe achievements. The materials evidence includes advanced understanding of stone properties, metalworking capabilities, and material processing techniques that required technological knowledge and capabilities. Approaching modern materials science. Archaeological analysis reveals material processing techniques, property understanding, and application methods that demonstrate technological sophistication exceeding what traditional models acknowledged. For Paleolithic technological development, recent materials analysis reveals pre-impact understanding of material properties and processing capabilities that approach sophistication levels not achieved again until much later technological periods. Energy technologies reveal capabilities for energy generation, management, and application that enabled advanced technological applications and manufacturing processes that weren't achieved again until modern industrial development. The energy evidence includes technological applications that required energy generation and management capabilities exceeding what natural human and animal power could provide, indicating access to advanced energy technologies. Archaeological analysis reveals technological achievements that required energy applications and management systems exceeding what traditional models acknowledge. For pre-agricultural technological capabilities, recent energy analysis reveals pre-impact technological applications that required energy generation and management capabilities approaching levels not achieved again until modern industrial energy development. Information storage technologies reveal knowledge preservation capabilities that enabled complex information retention, transmission, and retrieval systems that exceeded post-catastrophe knowledge preservation for thousands of years. The information storage evidence includes symbolic systems, knowledge encoding techniques, and information preservation methods that required technological sophistication approaching modern information storage capabilities. Archaeological analysis reveals information preservation and transmission systems that demonstrate technological capabilities and organizational sophistication exceeding traditional models of Paleolithic cultural development. Recent information analysis reveals pre-impact knowledge preservation and transmission capabilities that approach sophistication levels not achieved again until much later. Technological and cultural development. Quality control technologies reveal manufacturing and production oversight systems that achieved consistency, standardization, and quality assurance that exceeded post-catastrophe production capabilities for millennia. The quality control evidence includes production standardization, quality assurance systems, and manufacturing oversight that required technological sophistication and organizational capabilities approaching modern manufacturing standards. Archaeological analysis reveals quality control achievements and production standardization that demonstrate technological capabilities exceeding what traditional models acknowledge. For Paleolithic manufacturing development, recent quality control analysis reveals pre-impact manufacturing and production oversight capabilities that approach sophistication levels not achieved again until modern industrial development. Integration technologies reveal capabilities for coordinating multiple technological systems, managing complex projects, and organizing technological applications that exceeded post-catastrophe integration capabilities. For thousands of years, the integration evidence includes technological coordination, project management capabilities, and systems integration that required organizational and technological sophistication approaching modern project management standards. Recent integration analysis reveals pre-impact technological coordination and systems management capabilities that approach sophistication levels not achieved again until much later technological and organizational development. The systematic loss technology evidence demonstrates that pre-impact cultures achieved technological sophistication that exceeded post-catastrophe capabilities across multiple domains including manufacturing, engineering, astronomy, transportation, communication, materials science, energy management, and information storage. The convergence of technological evidence establishes that cosmic catastrophe eliminated advanced technological knowledge and capabilities that required thousands of years to redevelop, indicating civilizational destruction that eliminated sophisticated technological systems and forced technological restart from primitive conditions. Survivor accounts. The most compelling evidence for cosmic catastrophe and advanced civilization destruction comes from survivor accounts preserved in oral traditions, flood myths, and cultural memories that describe exactly the type of cosmic impact event and civilizational collapse that geological evidence confirms occurred 12,800 years ago. The survivor account evidence begins with global flood traditions that describe cosmic fire, falling stars, and worldwide destruction that eliminated previous civilizations while forcing survivors to rebuild from nothing. These accounts appear in cultures worldwide with remarkable consistency in describing cosmic catastrophe details. The Hopi tradition describes the destruction of the Third World through cosmic fire and worldwide flooding that eliminated advanced civilizations, forcing survivors to flee to the Fourth World. The Hopi accounts include specific details about cosmic objects, environmental catastrophe, and civilizational collapse that match scientific evidence for cosmic impact. Hopi elder accounts describe previous worlds that achieved technological advancement and global communication before cosmic destruction reset human development. The technological descriptions include flying vehicles, global communication systems, and advanced engineering that exceeded current human capabilities. The Hopi traditions preserve technical knowledge about astronomical cycles, cosmic catastrophe timing, and environmental patterns that demonstrate sophisticated understanding of cosmic processes and catastrophe prediction capabilities. Recent interviews with Hopi traditional keepers reveal detailed accounts of previous civilizational achievements and cosmic destruction that provide specific information about technological capabilities and catastrophe mechanisms that match scientific evidence. Hindu traditions preserve detailed accounts of cyclic cosmic destruction through cosmic weapons and environmental catastrophe that eliminated advanced civilizations during previous cosmic ages. The Hindu accounts include technical descriptions of cosmic weapons and environmental effects that match cosmic impact scenarios. The Mahabharata describes weapons that produced effects matching nuclear and cosmic impact descriptions, including blinding light, environmental destruction, and long-term environmental contamination that prevented habitation for extended periods. Hindu cosmological texts describe cyclic time and cosmic destruction that eliminates advanced civilizations at regular intervals, forcing civilizational restart and technological redevelopment through successive cosmic ages. Recent analysis of Hindu texts reveals technical descriptions of cosmic weapons and environmental effects that provide detailed information about cosmic catastrophe mechanisms and advanced technological capabilities. Norse traditions preserve accounts of Ragnarok that describe cosmic destruction through falling stars, environmental catastrophe, and civilizational collapse followed by world renewal and population restart from surviving remnants. The Norse accounts include specific descriptions of cosmic fire, environmental destruction, and civilizational collapse that match scientific evidence for cosmic impact effects and environmental catastrophe. Edda texts describe advanced technologies and cosmic knowledge that existed before Ragnarok destruction, including detailed astronomical knowledge and technological capabilities that exceeded post-catastrophe achievements. Recent analysis of Norse traditions reveals technical knowledge about cosmic cycles, environmental catastrophe, and civilizational collapse that demonstrates sophisticated understanding of cosmic catastrophe processes. Native American traditions across multiple tribes preserve accounts of cosmic fire, starfall, and worldwide destruction that eliminated previous advanced civilizations while forcing survivors into primitive subsistence conditions. The Cherokee tradition describes previous worlds that achieved technological advancement before cosmic destruction eliminated civilizational achievements and forced survivors to rebuild from primitive conditions. Lakota traditions preserve accounts of cosmic catastrophe that includes falling stars, environmental destruction, and civilizational collapse that forced population dispersal and cultural simplification. Recent collection of Native American accounts reveals consistent descriptions of cosmic catastrophe, advanced previous civilizations, and environmental destruction that match scientific evidence for cosmic impact and civilizational collapse. Australian Aboriginal traditions preserve accounts of cosmic catastrophe and advanced previous civilizations that achieved remarkable technological capabilities before environmental destruction eliminated their achievements. Aboriginal Dreamtime accounts describe previous times when people possessed advanced technologies including flying vehicles, global communication, and environmental control capabilities that were lost during cosmic catastrophe. The Aboriginal traditions include detailed astronomical knowledge, environmental understanding, and technological descriptions that demonstrate sophisticated knowledge preservation despite cultural simplification. Recent documentation of Aboriginal traditions reveals detailed accounts of cosmic catastrophe and advanced technological capabilities that provide specific information about pre-impact civilizational achievements. African traditions preserve accounts of cosmic destruction and advanced previous civilizations through oral histories that describe technological capabilities and cosmic catastrophe events that match scientific evidence. The Dogon tradition includes detailed astronomical knowledge and accounts of cosmic destruction that demonstrate sophisticated understanding of cosmic processes and catastrophe mechanisms. African flood traditions describe worldwide destruction through cosmic fire and environmental catastrophe that eliminated advanced civilizations while preserving limited populations in refuge areas. Recent collection of African accounts reveals consistent descriptions of cosmic catastrophe and advanced civilizational achievements that match evidence for cosmic impact and civilizational collapse. Greek traditions preserve accounts of previous golden ages that achieved technological advancement before cosmic destruction eliminated civilizational achievements through environmental catastrophe. Plato's Atlantis account describes advanced civilizations that achieved remarkable technological capabilities before cosmic destruction eliminated their achievements through environmental catastrophe involving cosmic fire and flooding. Greek flood traditions describe cosmic destruction through divine intervention that eliminated advanced civilizations while preserving limited populations for civilizational restart. Recent analysis of Greek traditions reveals technical descriptions of advanced technologies and cosmic destruction that provide detailed information about pre-impact civilizational capabilities and catastrophe mechanisms. Mesopotamian traditions preserve detailed accounts of cosmic destruction and advanced previous civilizations through texts that describe technological capabilities exceeding contemporary achievements. The Sumerian king list describes antediluvian civilizations that achieved remarkable longevity and technological capabilities before cosmic destruction eliminated their achievements through environmental catastrophe. Mesopotamian flood accounts describe cosmic destruction through divine intervention involving cosmic fire, environmental destruction, and civilizational collapse that forced civilizational restart. Recent analysis of Mesopotamian texts reveals technical descriptions of cosmic catastrophe and advanced civilizational achievements that match scientific evidence for cosmic impact and technological capabilities. Egyptian traditions preserve accounts of previous civilizations and cosmic destruction through texts that describe advanced technological capabilities and environmental catastrophe that eliminated civilizational achievements. The Egyptian Edfu texts describe previous civilizations that achieved advanced technologies and cosmic knowledge before environmental destruction eliminated their achievements and forced civilizational restart. Egyptian astronomical texts preserve detailed knowledge about cosmic cycles and catastrophe timing that demonstrates sophisticated understanding of cosmic processes and catastrophe prediction. Recent analysis of Egyptian traditions reveals technical knowledge about cosmic catastrophe and advanced civilizational capabilities that provide detailed information about pre-impact technological achievements. Celtic traditions preserve accounts of previous advanced civilizations and cosmic destruction through oral histories that describe technological capabilities and environmental catastrophe that eliminated civilizational achievements. Irish traditions describe previous civilizations that achieved advanced technologies and global capabilities before cosmic destruction eliminated their achievements through environmental catastrophe. Celtic astronomical knowledge preserves detailed understanding of cosmic cycles and catastrophe timing that demonstrates sophisticated knowledge preservation despite cultural changes. Recent documentation of Celtic traditions reveals detailed accounts of cosmic catastrophe and advanced technological capabilities that match scientific evidence for cosmic impact and civilizational collapse. Andean traditions preserve accounts of previous advanced civilizations and cosmic destruction through oral histories that describe technological achievements and environmental catastrophe. Inca traditions describe previous civilizations that achieved advanced engineering and astronomical capabilities before cosmic destruction eliminated their achievements. Andean astronomical knowledge preserves detailed understanding of cosmic cycles and catastrophe. Prediction that demonstrates sophisticated knowledge preservation. Recent collection of Andean accounts reveals consistent descriptions of cosmic catastrophe and advanced civilizational achievements that match evidence for cosmic impact and technological capabilities. Knowledge preservation analysis reveals that survivor accounts preserve technical information about advanced technologies, cosmic catastrophe mechanisms, and civilizational capabilities that wouldn't be maintained through normal cultural transmission. Unless based on historical experience, the knowledge preservation evidence shows technical accuracy, detailed descriptions, and consistent global patterns that indicate historical experience rather than mythological creation. Recent analysis of knowledge preservation reveals sophisticated technical information and accurate cosmic knowledge that demonstrates historical basis for survivor accounts, rather than fictional creation. The systematic survivor account evidence demonstrates that global traditions preserve detailed historical accounts of cosmic catastrophe and advanced civilizational destruction that match scientific evidence for cosmic impact 12,800 years ago and provide detailed information about pre-impact technological achievements and post-catastrophe survival. The convergence of global traditions establishes that cosmic catastrophe eliminated advanced civilizations while forcing survivors to preserve cultural memories of technological achievements and environmental destruction through oral traditions that maintained historical accuracy despite cultural changes over thousands of years.